In CogWorks Week 1, we learned about audio analysis, aka getting the frequencies and amplitudes from a sound recording. At the end of that week, we worked on a song recognition project. For CogWorks++, we not only recognized audio, but we transcribed it. Our audio transcriber takes in an audio recording or file and outputs what notes are being played and how long they are being played. In this instance, we're recording a C scale being played by a tone generator as shown. Our program outputs the notes being played at different time intervals in the order of their amplitudes, the loudest being the first one shown. Since we played a C scale, we can see the notes corresponding to our scale being the first ones outputted. C4, D4, E4, F4, G4, A4, B4, and C5.
In the second week of CogWorks, we learned about image recognition and image classification algorithms. And as part of that week, we made the capstone project where we implemented the Whispers algorithm, which essentially takes a folder of images and clusters them together based on how identical they are. And for CogWorks++, we took that a step further, and now when it clusters the images, it also creates subfolders for the clusters it found. And as a small demonstration, here's how it would organize a folder of a few images ranging from a few celebrities to a team member, our instructor, and our TA. First, allow me to draw your attention to this graph, which is a small representation of what it would look like. Each node is an image, and the color represents a cluster it belongs to. So now if we go to the photos, you can see that certain folders contain images clustered together. And there's even an unclassified for images that contain more than one face.
We also made a movie recognition program using what we learned about facial recognition from week 2. This program, which we call Movie Shazam, takes an input of an image from a movie and identifies the actors and actresses in the movie using a pre-trained neural network in a large database. Then it identifies the movie based on the actors identified using a large database of popular movies. Here, we're demonstrating this program using some test images. And here, the program has correctly identified the movies as Titanic and Speed and identified the actors and actresses inside the pictures.
Week 3 of CogWorks revolved around natural language processing, and early on in the week we coded a character-based n-gram language model which looks at the inputted text in windows and uses the previous letters to predict what the next letter could be. These predictions, in the form of probabilities, can then be used to generate new text, which we did with Shakespeare. In CogWorks++, we're expanding on this concept by using an n-gram language model that is word-based to ensure that the output is actual English, and training it on a large database of lyrics from 20 artists to see if we can generate song lyrics in a given artist's style. To demo this, if I run the Python file, it will prompt me to enter an artist from this list. If I enter Adele, for example, and then 100 words, it will generate 100 song lyrics split up into lines to mimic song formatting in the style of Adele. Now, if you want to try again, just enter Y, and it will restart the process. However, if you enter an artist that is not in the database, then it will prompt you to try again or quit. And that's our lyric generator.
CogWorks++ sentiment analysis, which is capable of telling whether a phrase is positive or negative based on its training on a little under 1.6 million tweets. So it can correctly identify a positive phrase like "I love Beaverworks" or a negative phrase like "I hate rain." And that is all.